All right, we're going to be taking a look at the trig ratios for a given point. We're going to need to also have these notes down to the right here. I'll probably pause the video and let you get these down. These are our trig ratios. These are a little more designed for a coordinate planes than the actual triangles. We also know the SOHCAHTOA and all this stuff. It's still the same thing, but in this case, this is just a little more designed for, like I said, the coordinate planes. Before we get into really the heart of all this, we're just going to kind of go back into the trig ratios, just kind of touch on these real fast. We're going to find the exact cosine value, and we're going to simplify the radical when that applies. So in this case, we're looking for the cosine of angle A. So it helps if you label your angle, and then remember cosine is the ratio. Cosine of an angle is equal to the adjacent angle over the hypotenuse. So in this case, our adjacent angle is the angle that it touches, angle 5, and then the hypotenuse is the angle 10. So what we have here is a trig ratio of 5/2. Excuse me, 1/2. 5/10 is 1/2. So our ratio here would be cosine equal to 1/2. Now the radicals stayed out of here, but let's discuss real quickly how we do reduce a radical, like the number the square root of 75. If we're going to reduce a radical, the factoring tree, and then we're just going to look for pairs. So 3 times 25 is a form of 75, and this would be 5 times 5, and then those are all prime numbers. Remember, anything that pairs out gets out. So this pair of 5s gets out of the radical. So this would be rewritten as 5 on the outside. And since the 3 did not pair out, it's stuck on the inside. We didn't need that on this particular question, but we may later on. Take a look at another one here. This one asks for the angle A's tangent value. So our A value. Tangent, remember, always involves everything but the hypotenuse, and it is opposite over adjacent. So the opposite angle is the angle, or opposite side is always the side that it does not touch. In this case, that would be side 2. And then the adjacent side is the touching side that is not the hypotenuse. This would be 2/9, which does not reduce. Put a little reminder as well, just to keep in mind. Tangents can be a larger numerator than denominator. Remember, cosine and sine cannot. This one we're given our angle measurements, and we're given our cosecant, and we're looking for the cosecant of angle H. Well, first thing I'm going to do is mark angle H, and then I'm also going to come over to the right and just identify what cosecant is. Remember, sine, cosine, and tangent are our traditional trigs, but they also have their reciprocals, and the reciprocals are always the opposite letter. For instance, sine goes with cosecant, the one that starts with an S goes with the one that starts with a C. The one that starts with a C, cosine, goes with one that starts with an S, secant. And then cotangent, the ones that have T's go together. So when we're looking at this sine function, the sine function here will correlate with the cosecant function. You don't have to break it into this form. You're welcome to use the study guide sheet that I gave you at the beginning that said cosecant was equal to the radius over the y value. You can just set that up and that will be fine. But I'm going to set this up in the triangle form. So when we're looking at this, I'm actually going to work through sine. Sine of this angle is the opposite side here. So opposite to this would be the angle 56. I'm doing sine of H at the moment. Sine of H equals 56 over the hypotenuse, which is always opposite of the right angle. This would be 65. So if sine of H is 56 over 65, then cosecant of h is the reciprocal of that, and the reciprocal, of course, would be 65 over 56. So this is what we're looking at now. This is the angle of the function. We've been dealing with everything that falls on the unit circle, which is one radial measurement. This one, we are going to start to deal with things that are a little bit differently. These radiuses are going to be longer, obviously. They can be shorter, but they're generally going to be longer than one. So here's our instructions. This says the terminal side passes through the point 12, 5, negative 5, excuse me. So in this case, what we want to do is generally construct our triangle here. You can see I pulled this off here and I already have my coordinates. And the point 12, negative 5 is in the fourth quadrant, 12 units to the right and 5 units down. Now you can see this is totally not to scale because 12 is a bigger number than 5. But we don't have to worry about the scale. All we need is the picture. This is just a generic picture. So we need to find, in this case, we're looking for cosecant, which again, that is the inverse of sine, reciprocal of sine. So if we can find the sine of our angle, and it's always the angle that touches the origin. Well, this one is labeled, but even if it was not, we would do this. And we're trying to find the measure of the reference angle, because remember the reference angle is the angle's distance from the x-axis, so that would be this angle. So we've already got our triangle there. I'm going to try to draw mine a little more to scale than this. Since the side is 12, it's probably going to be a little more like this. Coming from the origin, 0, 0. We would go over 12, so this would be a side of 12. This would be a side of 5. Now, sine does require the hypotenuse, which we don't know yet, but we can use our Pythagorean's theorem. Now, you notice I have a negative 5 there, or a positive 5 there. We could use negative 5 as well. That's what it has. But Pythagorean's theorem is going to fix the negative sign anyway. So it would be negative 5 squared plus 12 squared will equal our hypotenuse squared. And once we have our hypotenuse, what we will do is we will put this back together and use those trig ratios. So this would be h, this would be 169 equals h squared. I'm sorry, I left my squared off of there. And in order to get the h by itself, we're going to need to take the square root. And the square root is technically plus or minus 13. But a hypotenuse cannot be negative. The other two can be negative, and that's dependent on what quadrant they're in. But the hypotenuse is not going to be negative. So we will ignore the negative version of the answer and only accept the positive 13. So this has a hypotenuse of 13. So now that we have a hypotenuse, if you don't need to go through sine, then don't. But I like to go through sine of the angle that we don't know. And remember, it's always the one that touches the origin. That would be this angle right here. Is opposite, which is 5, over the hypotenuse, which is 13. So if sine is 5 over 13, cosecant, which is the one we're looking at, will be the reciprocal of that, 13 over 5. And we'll take a look at one more. And we also need to recall that the negative 5 was our y value. So this actually should have been negative 5. So our answer should be negative 13 over 5. So this example, if we are looking for an exact value of secant, secant again is the inverse of cosine. If we were looking for the inverse of secant, pull this down, that passes through the point 7, negative 4. So 7, negative 4 is going to be in the fourth quadrant. So I don't need to draw the whole coordinate planes, but I definitely need to see a lot of the fourth quadrant. So this is where we would be. We're looking for the point 7, so that would be over 7 and down 4. So the terminal point would end right there. Now, make sure when you construct these triangles that you touch the x-axis, not the y. When we're constructing this thing, some people will go in here and attach it to the y-axis. We don't want to attach it to the y-axis. We want to attach it to the x-axis. So this is going to drop straight up, drop. It's going to go straight up just like this. So we're going to be looking at a triangle, right triangle, that has a side of 4, excuse me, and then it has a side of 7. And again, that is -4, but we are just going to deal with the positives right now. You are welcome to write that, but Pythagorean's theorem is going to fix this anyway. So we're looking at secant, which, remember, secant is the reciprocal function to cosine. So if we can get the cosine, we can work our way backwards into secant. And if you want to use the chart that I gave you at the beginning with the 6 terms, you can also look at that and just recognize that R stands for the radius. Regardless of what you do, we need to first find what is this radius. So using the radius in Pythagorean's theorem, we are going to go 7 squared plus, we'll go ahead and use the -4. -4 squared equals the hypotenuse squared. Or let's call it the radius, why not? So this is the radius squared. So this would be 7 squared is 49. 4 squared is 16. And this is radius squared. And 49 plus 16 would be 65 equals the radius squared. And remember, in order to get the radius by itself, the way we get rid of a square is with a square root. So we will be square rooting this. And again, it is the plus or minus square root of 65, but we're dealing with a distance here on this. This is a hypotenuse, so this would not be the negative version of this. It would only be the positive. So my hypotenuse would be the square root of 65. Well, let's take 65 to the side here and make sure that this does not simplify anymore. 5 times, I believe that would be 13. Both of those are prime numbers, so we can't factor anything else out of this. So that means the square root of 65 is the simplest form. That also means that our hypotenuse has a value of the square root of 65. So now that we have our hypotenuse, we can turn our cosine, and then we can turn our cosine into secant. So again, cosine, it's always the angle that touches the origin. That would be this angle right there. Theta is always touching the origin, and it's always touching the x-axis as well. Don't use the y-axis. So cosine is adjacent, which that would be 7, the angle that it touches, over the hypotenuse, which in this case is the square root of 65. Now, normally we don't leave a radical in the denominator, but we are converting this thing to secant, so the problem solves itself on that. So secant is the reciprocal function to cosine. So we'll move the square root of 65 to the top and the 7 to the bottom, and then we have our secant ratio. Notice I didn't give you any tangent or cotangent measurements. We shouldn't need to use Pythagorean's theorem if we have tangent or cotangent, because we don't need the hypotenuse to do either of those two. So all we've got to do is set up the ratio. Now keep in mind, tangent doesn't have the rules where the denominator has to be bigger. Neither does cotangent. They can both be either one. Just make sure, you may want to graph those things. You may want to draw and construct it so that you are using the correct opposite and the correct adjacent. But if you use the formula from the beginning, if you use that formula, you should be able to just put together your x and your y in the correct order. On sine, or excuse me, on tangent, the y value goes on top, x in bottom. Cotangent is the reciprocal, x on top, y on bottom. All right, good luck.